in case you want to use this kind of upload code in the Google Web Store. Apparently they did some kind of audit. They used to have like a manual audit if the application the API, but now they do automatic checks only if you just like have a HTML and JavaScript files, and this is actually what you need. So let me show you a video. We go to a web store with an extension that we want to backdoor, for example, Gmail, Google, official one. I will speed it up a bit. This is the code that is going to be in the extension. So we are going to backdoor it, adding this code. The code is using the Chrome extension API. As you can see, every time the user opens a new tab, inject my malicious JavaScript. And this means that you can control whatever is going on with content. You can do actions on the user behalf. So you can use either Beef to do that, or you a tool that very cool tool that basically only for Chrome extension exploitation, and this is the one that I'm gonna use right now. But again, you can easily Beef. You just need to like create the proper vector pointing back to your server. So here we are generating the proper hook. It's going to be the one injected in every tab. And so a script that we wrote that basically downloads the extension, the sent through Gmail valid extension that already exists in the web store that we want to backdoor, the JavaScript effect, and then the on the extension to have. So for example, access all tabs, have bidirectional communication on HTTPS origin. Here I'm just going to show how the manifest is. So this is basically the manifest version 2, where you can see that extension is access every tab, do bidirectional communication on HTTP and HTTPS origin, which means that you can all of what is going on the browser. Then obviously when downloaded and can and then backdoored. So this is and once it's backdoored, the zip file is created, so it's ready to be uploaded. And instead of you just need to basically give to the Ruby script like you need to be logged in the web application. Just put like your cookie values, and then the Ruby script automatically does all the requests for you and uploads the extension Google Web Store. This is the configuration file. You just need to add a bunch of things. It's exactly the same as we are going to see in a moment. HTTP requests and uploading the binary content to the store. And after a bunch of seconds, the extension is going to be published. As you can see, it gives you the published URL. And the only thing that differs, obviously you need to wait depending on like how big is the queue that they need to process, like 60 an hour and a half. But then the thing that is different is this, like ratings or like how many users installed it. All the rest is exactly the same. And once you did that, so your backdoored Chrome extension is uploaded in the web store, what you can do as the next step is use it during your social engineering engagements. So this is the backdoor. So we are going to use the Beef social engineering extension that I wrote back two years ago, before I gave a talk at Fort London. So you can the first thing you can do is you can use the social engineering extension via RESTful API. So you just need to basically create your social engineering email template with HTML or plain text, and then say, okay, this is the link I want to show here, and then this is the recipient. This is how I want to spoof the. And with just like one request, you are going to send an email to your victim. As you can see, it looks like one of the emails, which has been just delivered and received by our victim. Meantime is running, obviously, in a way that as soon as the actually no, sorry, Beef is used only to send the email. Then we are using again Mosquito to run the session and your server. So we are going to clean cache and everything. Also, this is another feature that I'm going to show you at the end, which is implemented both in Mosquito and Beef, which is basically like XSS, which I'm going to briefly cover at the end of the video. So Firefox is a Chrome extension as a proxy. So this is the phishing email. When the victim clicks on the link, she's going to be redirected on the landing page in the web store with our extension. This is the kind of permission alert that the user gets, which is common. Many extensions require permission, for example. So this is going to be pretty common. And as you can see, on the as soon as the basically like which is using, and as you can see here, these are so Gmail, web store, example domain, and the InsomniHack website. And if you analyze what is going on behind the hood, the connection is made. This is the Mosquito web interface, where you can see as an attack different tab and row response. So you can also use, if the victim is logged in, as you control the Gmail, because your JavaScript is running via the Chrome extension, you can also like literally render that content that the user is seeing in his own logged in account. You can see it in your, in this case, Firefox, which is basically connected tool, and then when the requests are sent to when Firefox does a request to the server socket translates the HTTP request into JavaScript, which is injected then in the Chrome extension, and then is executed with the privileges of the user. So as you can see here, I'm browsing through the InsomniHack website, and that's on the left in the terminal, that's the whole traffic that is being generated from extension. So this is basically an example of how you can have complete control of what's going on in the browser. As you can see, this is a Firefox again. I'm logged in as the user in his own Gmail account, just because in this tab he's logged in as well. So you can have like full control, and the user doesn't know exactly what's going on. This is an example of how you can abuse Chrome extensions. Going further, as I said before, yeah, Firefox extension, they don't have any sandbox. You can read, write files, execute operating system commands. In Beef, I added a couple of modules, exploit modules, where you can basically create an and embed a VIL encoded executable, for example, which is going to bypass every antivirus in case the victim is installed in the machine. You get like your reverse meterpreter shell or whatever other payload you want to use. This is actually something that originally added to Metasploit, and then we ported it to Beef, adding a couple use cases to trick the user into really installing the extension. So I will show you later, we created like a fake missing plugin yellow bar. He needs to click like install extension, stuff like that. Also, we are almost done on doing the same thing that we did on the Chrome extension for the Firefox extension in terms of controlling every tab via JavaScript. This is going to be in beef soon. So the example of the Firefox extension is actually this one. I'm gonna skip all the payload creation and basic hooking via XSS. Oh, there you go. So now we have, this is the beef admin interface. We have, we can control, as you can see here. So you can, you even know that it's a VM. So in this, I'm gonna proceed with exploitation, but maybe you don't want to do that in a real case. When you execute the module, you just need to specify which extension you have, Brewing domain, because you can have multiple beef servers. The extension, as I said, is in this case with a encoded executable. As soon as the extension is installed, the executable is run, and the reverse shell comes back to your Metasploit reverse handler in this case. So this is what's going to happen. As you can see on the top, dynamically with JavaScript and CSS, top bar, when the user clicks on install plugin, the not found is like a bug in the video. So this is what is going to happen. And then once it's installed, you already have the session open. And you have your reverse shell. And then, well, you can do whatever you want. So other than this, another bunch of tricks that I want to show you. So you remember HTML applications, also called HTA. If you HTML files, you find millions of results. So this is definitely not a new thing, but it's actually pretty useful in my opinion. So this is a simple and harmless HTML application that is served via a Ruby web application server. The interesting code of the HTA, which is basically creating a new ActiveX object and then running it. This is actually the pop-up that the users see when you are the HTML. So as you can see, name and publisher is something that you can't modify. It's something that is working like this by default. So it's actually pretty interesting for social engineering purposes. And yeah, publisher Microsoft Windows. Instead of running a calc, obviously you can do something more clever, like running a PowerShell payload if the victim is on Windows Vista 7 or 8. In this case, the payload is basically using PowerShell inline expressions to download the actual PowerShell payload from another server. The payload is executed, and is all executed in memory. That's the best part. So I tried it with and Avira, free antiviruses. They obviously don't catch anything like this. And you can find them in GitHub. There are a couple of guys that wrote them, like Manifestation and another guy. Probably the best payload is this one from Matthew Graber that deals with both x86 and x86-64 platforms. So you don't need to basically fingerprint in advance and then adjust your payload accordingly. And again, nothing touches the disk, so you don't even need to obfuscate the payload most of the times. You can actually achieve the same thing, not only with an HTML application, but also with another legacy functionality that is present in Office, Microsoft Office, which are the macros. So macros by default are not disabled, but default behavior in latest versions of Office, like 2010 or even later, it's like the document contains a macro. The user see that kind of yellow bar, so you need to click enable content. If the content is enabled, basically, again, your PowerShell payload triggers. I'm going to show you a couple of videos as well. Actually, yeah, first of all, the HTA video. So this is like a social engineering email that I created saying, look, we are changing the website. You are going to see these two pop-ups depending on your Internet Explorer settings. Please do open and then allow. And believe me that it works when I do my. So we're going to start basically beef, serve the HTA payload, and Metasploit with a bunch of like auto-run scripts, like smart to automatically migrate to another process. And so this is a victim hooked in B, Internet Explorer 10 or 11. It works also in 11. So you just select the module UI for this module recently, so you don't have to configure all this stuff. You just need to specify thing in case you are. So in this case, we sent the module. This is the victim of Windows 7. Actually, no, we didn't send the module yet. Sorry, just moving Windows around. Yeah, execute. So unfortunately, I couldn't find a way, even playing with content disposition in line, to basically prevent this pop-up to open. To click, unfortunately. So when the user clicks open, in case I had a allow pop-up, but otherwise you would have seen the other allow pop-up. This is the HTA in the background. You can I modify the attack so you don't see anymore the pop-up, and then you get another shell again. Okay, the difference is the following. You didn't see the second pop-up simply because the website I was serving the HTA from, or a site that you compromise and the user has in the trusted sites in Internet Explorer. In this, remove it. I'm going to remove it from the trusted sites. Okay, remove the origin, and now you're going to see the second pop-up. So let's say a completely remote scenario, just to see the difference. So yeah, it looks like another browser because I deleted also the cookies and everything. It keeps track of browsers based on a cookie that is set. So you execute again the module, and this time you get still, open save, and then you get this. As soon as the user click allow, you get, as you can see on the bottom left, you get a shell, and then the payload is migrated to another process. The nice thing about HTA is that the HTML application is not executed, is not parsed Internet Explorer executable, but there is another executable involved, which is called mshta.exe. Now, out that friends of mine tried this module on Site Kiosk, latest version. Well, this is, I guess, is the only 0 day we have, because basically they couldn't reproduce, so they never fixed this. So basically, it's from Site Kiosk. So you use the very similar payload, still an HTA. So imagine the use case. You are doing a pen test on a Site Kiosk, or you are at an airport, and you have beef running or at the Site Kiosk machine. So with this, basically, you can. You just need to use the HTA attack with the PowerShell payload. So This is like the virtual machine with the side kiosk. We're going to see it. Yeah. Basically, in this case, it's saving it because like you are acting like the victim and the attacker the same way, of course, because you are sitting in front of the side kiosk. So in this case, it's saving the HTA instead of just opening and executing it. And then, boom, you have the reverse shell on Metasploit listening to you, and then you call the side kiosk machine. So I don't know if you're familiar with Phishing Frenzy, which is a tool written by Brendan McCann, a friend of mine that works for I'm helping him as well with like ideas and some phishing modules. We actually created for the HTA attack. So in case you use Phishing Frenzy, you can basically just use the HTA email template as a durable link to your phishing domain. This is all public code. You can go here and like use it. Oh yeah, sorry. This is actually the code that was used in the example to break out. So doing three things. First of all is killing watchdog, then is killing sitekiosk.exe, and then is finally executing. And these strange JavaScript objects are Internet Explorer only. As you can see, MS Blob Builder, it works only Internet Explorer. I'm sure that many people already tried to fudge it. I'm not sure if they got bugs out of it, but yeah, a Vimeo channel in case you want to watch them again. A few things that I want to speak about before the end of the talk is abusing UI expectation. This is something that most of the like discussed in my book, of course. As I said before, this works in Internet Explorer 10, is not patched. It's patched in Internet Explorer 11. So when you fingerprint the browser and you see that the version is 9 or 10, you can automatically the technicality behind it. So from Internet Explorer 8, modeless notification bars were introduced. Okay, pop-ups a bit better, and also together with this modeless bar, Explorer 8 introduced smart screen filter, which is like a kind of bullshit reputational based, which really doesn't work. So every time, for example, you are giving you an executable, that executable is actually run through the smart screen filter, and depending on what that the executable has, so if Microsoft already scanned it, you can actually get like a yellow bar if it's like all right, or red, for example, you know, a virus, malicious code, whatever. The trick is that Rosario Valotta, my friend, Symantec and Microsoft had an agreement, and if you use Symantec Enterprise Validation SSL certificate to sign your executable, reputation doesn't matter. So you can have basically a virus, you sign it with the valid certificate, so you buy a company, you get the certificate, I don't remember how, I guess it's less than $1,000, and then you can sign whatever you want until someone revokes it. And if you, like, smart screen validation is completely bypassed, so you automatically get a yellow bar. Second interesting thing is that these modeless dialogues can be controlled with keyboard shortcuts. And this specific thing is the thing that Internet Explorer 11. So if you want to click run, you can also press the R key. Depending on the version of Internet Explorer, you need to press Tab, R, or just R. Obviously, this is like dependent in Italian, so it changes. But obviously, when you can fingerprint the localization of the user. The trick is the following, that with the EVSSL from Symantec, you bypass, can control smart screen filter via keyboard shortcuts, but it's not there is a third trick, which is basically the following. If you spot behind the main foreground window, in the pop under you have executable that you want the victim to run. What happens is that for some reason in Internet Explorer, you can direct keyboards that are arriving in the foreground window to the pop under. The pop under obviously can be spawned exactly behind the main, so it's visible to the user. And then the only thing that you need to do at the end is displaying a fake captcha in the main window. And for example, if the user is using if the user is using an English browser, so R for run, you just display a fake captcha with the R, a couple of R keys as the first characters. The user click R, the R key press is directed, which triggers the smart screen filter run action, and then boom, you have another shell. So I'm gonna show you the version. Where is it? So here we are starting beef. This is the virtual machine with Windows 7 and Avast saying that, of course, we are protected. And actually, Avast, as you can see here, also runs some kind of Internet Explorer plugin that I guess is supposed to check for malicious stuff, but apparently doesn't do a great job. Yeah, we log in the beef UI of our Internet Explorer 10 version browser hooked, and you just need to go, we also mount the executable that we want to run in a way that can be served from beef once the user clicks the R key. So we just go to the module, we say the URL dropper that I want to execute on the victim machine, and as soon as this is you press execute. Obviously, I didn't bought the EVSSL certificate just for this, so this is like found online that is that certificate, and is also you can see the classic install dialog just for demo purposes again, completely silent. So you execute the module, and document body on click is overridden in a way that basically wherever the victim clicks, the fake captcha is actually displayed. So in a way that you can have a real legit site behind, and then through XSS you control that origin, and then you do this module. So this is what happens when the module is executed. This is the pop under, which I've not full exactly behind, but you can do that. This is just for demo. This is the fake captcha. And as you can see, as soon as the victim press R for rotten, yeah, there you go. This is basically the executable that is triggering. And if you do it with a normal dropper, you don't see anything. You just, again, for demo purposes. And yeah, and then every time the victim press R, again, the same thing pops up. So unless she closes the browser, yeah, you win. Yep. Okay, last minute. So a few words about Java exploitation. We don't have time to see signed Java applet in action, but again, it's not that useful anymore because from Java 1.7 update 51, you cannot run anymore self-signed applets. So you need to have a valid code signing certificate. Otherwise, the applet simply doesn't run. Obviously, if you have a signed applet, you can execute commands, you can read and write to the file system. You have full machine compromise under the Java with the privileges of the Java process. So then you need to do a privilege escalation in case. There are obviously modules in beef for this. In case you want to buy a certificate, you can just sign the applet and then deliver it through beef. Also, another limitation is that Chrome and Firefox implemented click to play, And now, basically, you need to have a valid code signing certificate. You need to trick the user to bypass, to click, to allow the execution in the click-to-play in the browser. Then Java has its own click-to-play implementation. So there are, like, at the end, too many clicks involved. But in Internet Explorer, yet again, thanks Microsoft, because basically they didn't implement the click-to-play click-to-play feature yet. So even in Internet Explorer 11, if the victim has the Java plugin installed and running Internet Explorer, you can still use eventually the Java applet attacks. I had some other stuff to show you, but 45 minutes or outro, yeah. So with some degree of magic trickery, I think you can still obtain good results without 0 days. Again, especially if you are not like targeting a or person in a specific company. It sometimes still work. Yeah, so you know, if you want to share 0 days with me later, I will be happy to listen to you. And yeah, that's it. If you have like maybe a couple of minutes for questions, and that's it. I'm done. Thank you. No questions? Okay.
back to AppSecUSA. Our next presentation will be hacking the Oracle application framework from David. So let's make sure we give him a big hand here, make him feel welcome. All right?
Thank you, Frank. My name is David Byrne. I'm a principal consultant with TrustWave Spider Labs. I've been working in information security for about 15 years now. Long time ago, I actually founded the Denver OWASP chapter. I haven't been active very much. I kind of feel guilty about that, but I've been involved in one way or the other with OWASP for a while. So this presentation is subtitled A Case Study in Deep Dive Pen Testing. And kind of the history behind this, I wanted to give a presentation about this topic after engagement was performed a couple of years ago with a colleague, and in the Oracle e-Business Suite, which is this massive collection of business applications, just about everything that you can think of that Oracle makes. And the vulnerability was quite simple. If you had a cookie named either OA Developer or OA Diagnostic 1, it would be effectively a hidden feature in the application. And among other things, you could, without any kind of authentication, obtain a list of all sessions, including administrator sessions on the server. So all you had to do basically was wait until an administrator logged in, immediately their start imitating that user. This is a very major piece of software from Oracle. It's one of their products, and this vulnerability, though, had been there for years and years and never discovered. And one of the reasons speculated is the application really hadn't had anyone take a deep look at it. It had surface pen testing, I'm sure, before, where scanners maybe had been run against it, but nothing that really looked at it. The way that we had discovered it was using some of the techniques that I'll be talking about later in this presentation that I would describe as pen testing. The approach towards penetration testing definitely can be more time-consuming, but it also is far more realistic for advanced threats, for attackers that are basically where a job of testing it. So if you don't choose your targets within the application, you could easily come away with vulnerabilities, but that wouldn't be a realistic or an accurate representation of the application security. Which requires that you have access to the software. It could be that you downloaded an evaluation copy from the vendor. Maybe you got a hold of the installation media. Limited access, either intentionally or through a vulnerability to the server, and you dumped the application. The idea is that once you have that media, or whatever the case is, once you have access to the software, reverse and come up with some very impressive results. Throughout the presentation, I'll be using a virtual, or rather, examples from a virtualized test bed. The application, if anyone's interested, open URL to ebsexample.com, port 8000, used in the presentation, and also the application to break it for everyone. It is not the best designed application, in my opinion, and so easy to knock over. Don't do scanners, don't change passwords, things like that. So it didn't take me very long in preparing for this presentation to kind of regret my choice. And by then it was a little too late because the conference had already accepted my paper. Application is, there's over 250,000 XML files, and that's just the files with XML extension. There's a lot of other files with Java classes that are comprised, which make it by far the biggest application I've ever looked at. And even if you 20 lines per class, which is an underestimate, you're still talking about millions and millions of lines of source code that are represented in the application. Some applications that I test, I would say that there's a very gross lack of documentation. This app, there's tons and tons of documentation, but most of it's terrible. I apologize, I'm not trying to beat up on you. It's just I'm venting a little here after months of my own frustration. There's some good things about it that make it ideal for a presentation, or not ideal, but make it suited. Oracle provides evaluation VMs that you can download from their website. Uncompressed, there are a single VM is 238 gigabytes. That's the one that's running. It uses file system compression, so that it's not quite that large on my disk. Setting these VMs up is rather complicated, and I'm not going to go into that at all. I just want to focus on the penetration testing aspects. When you start creating your virtualized environment for testing, regardless of whether it's an Oracle application or some other platform, if it's a large application, I have a few recommendations. One is that ext4 is a lot faster for this type of analysis than NTFS or HFS on the Mac. It's amazing what a difference it makes. However, Eclipse, I found, is much more stable in Windows. Again, and you're dealing with hundreds of thousands of classes, so this is beyond the normal type of behavior that Eclipse was probably designed for. The more RAM you have, the better. Of course, it's all Eclipse. It basically indexes your code base and allows you to, within under a second usually, retrieve the simple text queries. So I'm going to be going through several analysis strategies that you can use when you're reverse engineering a like this and doing a deep pen test. The first one's very simple. Look at the database. The VM has a database server running on it. It's obviously Oracle. There's tons of applications on it, so weak storage of sensitive data and default settings, things like that. So called Toad just grabbed a, grabbed every or password. This isn't obviously a very exhaustive analysis of the database, but we can get some results very easily. There's a lot of different tables that have password, but there's one in particular, or a couple in particular that I wanted to show. Come on. So this table with admin password, if we do from it, you can see that credentials are being stored in plain text with no kind of protection at all. Obviously, these are default. Another, it contains plain text passwords as well. So this is a very easy way that you can get some quick findings that are important as well for the client. To get overall, the place that I always start is looking at the running processes. So, there's a lot of Linux processes that you'd probably recognize, but as we start, sorry, hang on a second, there's icons getting in the way where you guys can't see. As you get, what you'll find is that there are a lot of, most of the processes other than the Oracle database server are running in the u01/install/apps. So the next step would be to identify the content that's on there. We know what directory it's in, and this is just a quick one-line script that will basically look at all the files in that directory tree and count them based on the extensions. Apologies, this works a lot different on my other system here. So the largest number of extensions are with, or files are with the class, which is to be expected since it's Java. It's a lot of XML files. As you can see, start going down the list. There's other formats, JSP, JS. You can recognize a lot of these, but the problem is they get in the way. It's not something that's very easy to handle. So what we need is some way of organizing all of this. One is that when you're trying to find content, if you have gigabytes and gigabytes that you're processing, it's going to take 2 engagements. So removing as many files as you can is ideal. It'll help speed things up. Identifying the files based on the extension, but also on the format, so using something like the file command. Emptying the media files, not necessarily deleting them, because sometimes it's useful to say, okay, browser requested background.jpg, where is that on the web server? Because I know where some other files I'm interested in are in relation to that graphics file. We'll speed up recursive greps and things like that. Being able to identify open source files is also very useful because reverse engineer open source. If you want to just go to Apache Commons and download the source code. There's quite a few classes, though, that in a project like this, source projects, that you can exclude. And then finally, being able to do things like identify duplicate files and extract any archives. So there's going to be a lot of WAR files and ears and jars and whatnot. Being able to see what's inside of those and do text analysis against them is critical. So there's a lot of different ways you can do that. I wrote a script that I use on projects called extract.pl. It's a Perl script that basically takes care of the things I mentioned on the last. Uses multi-threaded archive extraction. I have about 3 million hashes from public Maven repositories so that I can identify files that are and just and then it will basically sort everything out into a directory structure that's more usable. This is basically what the script looks like. It's configurable based on the type of file. So for example, which is a pattern of what the file command will output, you can define a number of regular that will match individual. So in this case, I just want to untar any tar files that are found. And it's quite a few different file formats and archive formats that it supports. So running this, I have a reasonably fast machine at home, but it still can take hours to run. It's an iterative process. Keeps track of which files it's touched so that it doesn't have to rescan anything. It will also list out, in this case, a lif file. I have no idea what a lif file is. But with the path, you can go and take a look at the contents and really check to see whether it's anything you need to be concerned about. So let's see, we can, once the files have all been extracted, the classes are one of the main targets that we're going to have for reverse engineering for the place. But types that are throughout the application, not necessarily going to be organized very well. There's another script we use called organize, and basically it uses a small Java application to extract the package name from the class file and then sorts them into a proper structure. And handling duplicates is one of the more difficult things with something of this size, and you end up just having to abandon them and hope it's nothing important. Once the files have been, or once the classes have been organized, you can see how many there were, 325,000 in this case. The next step is to decompile it. I use JDGUI. It's a pretty good tool. Some problems with it, though. Some counter, I'm guessing, will crash if you throw too much data at it. My suspicion is that it's something to do with a variable counter because it's not a specific number of classes, it's not a specific number of bytes. So you need to split up the classes, limiting the zip files that are created based on the total number of classes. Once that's done, excuse me, Java Decompiler is actually pretty fast. This is not sped up. This is actually how responsive it is once you've loaded a zip file. It will instantly decompile a specific class. This part is sped up. Unless you have a very fast processor, it'll take a little bit longer to generate a dump of all of the Java source code. And when you do it, organizes it into another zip file that's structured pretty much how you would expect based on package. Or actually, it's based on however you provided the organization. So once you have everything sort of organized and decompiled, there's a number of different strategies that you can take. My favorite is what I would describe as juicy targets. It's not very scientific, but after you've been penetration testing for a while, you kind of get a feeling for where vulnerabilities are more likely. So places that I like to look are files maybe with download or upload, some kind of diagnostic or debug tags in the name of them. Obviously simplification, but one advantage is that it can result in very rapid findings that are very significant. It might be a little more difficult for junior testers though, because it may not be as obvious to them where to look for things like this. And if you're doing any kind of thorough vulnerability assessment, it's completely very methodical approach. It's more spot checking. So the JSPs that are included with the Oracle application, there's quite a few that have download in the name. BIS download is one in particular that in Eclipse, once you've loaded all of the results of your decompiling and everything, it has some very useful and open resource by name. So I can just type in BIS download, and it will, after it's been indexed, it'll let me open it up very quickly. In addition to opening up the JS server uses compiled JSPs. It's not actually looking at the text file. It's looking at classes that are cached. So the name of this one, if you can read it, is the BS_BIS download.java. So it's basically the full representation of the JSP. It's also nice because you don't have to navigate throughout JSPs. So a lot of times if you look at a JSP, you'll see that there's an include that references another JSP. Have a whole series of these that make it rather difficult to read. When the JSP is compiled, all of those includes are put into a single class so that you don't have to really look around for the content that you want. So we can see the param request variable, which is just the browser. There's a number of cases where storing these into very thing that's useful about Eclipse is do refactoring on the fly. So I can refactor it. This is, sorry, I apologize. PowerPoint is being very erratic about when it decides to pause and when it decides to go forward. So you can rename these variables to something that's a little more useful that matches the purpose of the variable, and very similar if you've ever used something like IDA Pro, where you can rename pieces of data that will make it easier to track in the future. So there's a couple of vulnerabilities in this application, page. One in particular that we're going to look for is, so thought it would be a lot easier to do a demonstration with recorded videos, but I'm thinking that may have been incorrect. So on this line right here, that of local HTTP session. Now, if I was to try and open up the HTTP session, it unfortunately, because I discarded all of those open source projects. That included things like HTTP session, which is part of a standard Java class. So what get value is if you're not familiar with the application or with the framework. Is our friend here though. What we can do is look up just HTTP session get value. It'll pull up the Java docs on the right class, and what we see is that it's a method that basically just returns a variable in the session, a session data. The problem is that that is being called based on user-defined information. We don't really know what's in the session, though. And this is another thing that can be very useful when you're doing a reverse engineering techniques when you have a virtual machine running. I can go onto the virtual machine, the JSPs are stored, and create new content, basically. So I'm going to create a quick debug file that will basically just iterate through all of the recompile the JSPs, and a little more session data in the session. And when I request the debug, give a full dump of the output. Wow. Okay. So these are all the different session variables accessible to a user. It's not uncommon at all to see sensitive data in here, for example, user's password or perhaps I've been recording this and I was recording this in Brewing. We grab the some of the variable names, and object key is the parameter that the JSP is using. That in for into the repeater. So object key is whatever this button message, just some random session variable, and it returns the data. So this is something that, for example, cross-site scripting would be great for exploiting this. If you were targeting a specific user, you could start extracting information in there. Also use it against your own session to look at, like I said, things like database connection strings. If you grep through the source code, you can see a number of cases where the application, the Oracle application, is putting value in the HTTP session that it really shouldn't be. I think it scrolled by the ones that I wanted to show, but basically it's putting, here we go. Anyway, just take my word for it. It's putting some passwords and other information that it shouldn't be in there. So the next strategy that I would use is something I might call advanced grep. This is a simple script that I threw together. Basically, it just looks at a JSP or a series of JSPs, identifies where it is grabbing, where parameters are being pulled from the request. So, some basic information. And what we can do is, well, here, this video shows real quick a quick run. All right, so this is a simple output of the script. You can see what it's doing. This is a constant, so something param. It's grabbing from the request, the script is, and putting it into the root variable. Then later on down, we see that it's being dumped out without any kind of output validation. There's a lot of poor output validation in the Oracle framework here, but they actually check for some strings. So for example, you can't just throw a script tag in there or something like that. All that we're doing with this script is looking for cases where validated input is being put into an existing script, because that makes it a lot easier to come up with an exploit string. So if we request this page, it's just some kind of category picker. We can pass root to it, just throw in something like ASDF, and in the source code we can see what the output context is. This is pretty simple. We need to escape from a single quoted string and then from a function, and then we can write whatever JavaScript we want. So going back to the request, we'll escape out, put in an attack string, create a new function, which is no surprise. So one thing that's interesting though, the script isn't perfect. It misses a lot, but it doesn't have a very high false positive rate. And if you look, well, basically the script, here we go. If you see it, look at the very bottom, and of course it's covered up. Basically there's about 150 different cases of cross-site scripting in the JSPs there. There's also static analysis tools that can be used. There's a lot of commercial products, some free open source products like find bugs. Of course, anything that's automated, there's certain advantages, but a lot of the tools aren't designed for mammoth applications. Like in this case, several 100,000 classes. So it can require some very hefty computing resources. And also there's a lot of dead ends just because they're, the nature of false positives. With find bugs, you can get some information. So here, what I'm doing is basically inputting a classes.zip file, which is all the classes zipped up into one archive, and then providing it with the all of the jars that are referenced so that it can basically resolve dependencies. And then the source directory so that it can show where in the source code it is. So it found a lot of security vulnerabilities. Some of these are real, some of them aren't. If we open up one of them, we can find it's in Git minifier, or excuse me, it's in minifier filter. I'm not sure exactly what that is, but we can open it up in Eclipse very easily. And it told us that it was a directory traversal. Now, one thing to keep in mind, it's going to be giving the line numbers based on what the class file reported, which once you GUI or any kind of decompiler, it's not the actual text line numbers, but it will put the line numbers from the jar or from the class file column. So we can find where it reported the vulnerability. And here we go, it's opening a file name. Where does it get cache file name? It gets it from the request URI. That's a very insecure way of doing it because there's no validation here. So this is path traversal. The challenge though is how do we get to this? And this is one of the challenges with a lot of the types of, you might be able to find a vulnerability in the code, and I am certain that this is a example of path traversal, but actually being able to exploit it, to call it, very challenging. So if I open up the call hierarchy of minified bundle, and basically you'll see that it doesn't find anything. Now, it is a class that's used, but it can be it's very, very difficult to track down how to access it. So sometimes you end up with dead ends like that that just aren't worth pursuing. Another strategy is inside to outside, which I would kind of describe as reverse taint checking, where with taint checking, you're tracking comes in and seeing if it's ever properly validated. With reverse taint checking, that's not a term, but you're looking for key functions. So for example, it could be calls to a database, looking for SQL injection. It could be opening up new files. Last example, we could have looked for all the constructors to file that, and then tracing backwards. The advantage is that you can on very specific types of vulnerabilities. So if you're looking at all of the calls to JDBC handle, that's a very thorough way of checking for SQL. But on the other hand, we saw in the last example, it's difficult to actually discover how the vulnerability should be exploited. In case I'm execute query, it is being called execute query, of course, is just a common way of calling SQL, and not necessarily the best way because it's using just string as opposed to any kind of prepared statement. It's in the statement, rather the statement interface, which is normal. And if we open up the call hierarchy, which is an Eclipse method that calls that method. So we basically you can go in and open up each one individually, and in the first case, we see here, but plan ID is also is defined as int. So there's no way that you can exploit that. It's bad practice, but not. Going on to that, we can look for some more, and in this case, the method is calling, again, dynamic SQL. Table name, though, that it's coming in. Now, we don't know from this context how table name may have been validated earlier, but this is absolutely poor practice and could easily result in a SQL injection vulnerability. In order to determine if it was actually exploitable, we'd have to track back through the call hierarchy and find where it was accessible from users. Reviewing log files is another that can be useful. So let's say that we have we've discovered a Oh, these aren't movies. These are just screenshots. That's why it wasn't working. So let's say that we've gone to the and we found something called XDP XML query. Who knows what it is? If we request it, we just get a blank page. It doesn't necessarily mean that it's broken. It just means that something for direct looking for any files in a narrow time frame. We can avoid getting a lot of false positives. So most of these, for our purposes, useless files, but there's two in particular. One is the access log. Now, we don't really need to look at that. The access log is just going to tell us what we requested. But the application log is going to be the most useful. And if we were to open it up, we could see that an error when we requested that JSP. So if we were to, we could do basically like a tail-f, and we're sending requests and end up getting a lot more information that way. The last strategy, taint checking. Being able to identify the external interfaces, trace the execution flow. Input is enters the system, and then identify how how vulnerabilities might result from that. This technique is much easier to exploit, kind of like the advanced grepping. It gives you something right off the bat that you can start to use. But there's a lot of dead ends because presumably user input is going to be vulnerable. And I had a video for this, but it got messed up, so that is all.
switch. Up here. Okay. I'll turn it off in a minute.
Yeah, so hello everybody. We're going to discuss tricks and techniques and trade-offs around detecting unwanted headless browser visitors on the websites and ways to bypass those detection techniques.
So to introduce ourselves, my name is Bei Zan. I'm a software engineer at Shape Security. Before that, I worked for Chrome team, Google's Chrome team, and focusing on the Chrome apps API, which contains a lot of security concerns in the thing. And currently I'm focusing on web security, source code analysis, and algorithms.
And again, I'm engineer at Shape as well. I work on mainly on like web security stuff. And prior to that, I was working at Qualys for vulnerability scanner engine. And yeah, that's about ourselves. So just to what headless, imagine a developer tools enabled without the actual Chrome UI, but with JavaScript API to that developer tools. So headless browsers can be grouped into 3 categories. So so first category would be some tools that have a real web browser engine backing them. Those are like Phantom.js, WebKit engine, or Slimer.js, which is similar to Phantom.js and even has the same API, JavaScript API. It's backed with Gecko. JS is a Trident engine, which is IE's heart. And another category would be something that looks like a browser from a programming point of view, but it's not really a browser. It doesn't have a real browser engine in it. And Zombie.js or HTML unit Zombie.js is not JS-based, which mimics a browser, and HTML unit is Java-based. And third group would be to actual browsers that support WebDriver API, and like all major browsers do support, with Selenium server. So you can control a remote browser, local browser with a Selenium script that's loaded into Selenium server. And yeah, that's another way to control the browser. But mostly focused on JS because of the reasons listed on. And another reason of Phantom.js, we have some. So Bay will introduce the basic architecture of how Phantom.js works.
Yeah. So this is how Phantom.js works. In Phantom.js, there are two different kinds of JavaScript contexts. Because Phantom.js is Phantom.js JavaScript engine context directly initiated by Phantom.js. And from that context, you can generate different pages, a series of pages, and each page will be a Q web frame, which is part of Qt WebKit widget. And inside the Q web frame, there is a Qt WebKit engine, and also there is a WebKit. There's a web page JavaScript context. Then from the Phantom.js JavaScript engine context, you can control the page, and you can the events sent from the WebKit engine, and you can also inject your JavaScript code directly into the JavaScript context page, and you can also from the page calling some functions, not really functions, but there's a mechanism to actually call back from the web page into the Phantom.js. So a simple code to use Phantom.js will look like this. So this is something look like the Node.js, the require. Then you require the module web page. Then you call create on it. You will create a page that is running WebKit inside it. Then you open a URL on the page. After the page is opened, then you can there a pointer? No. So then you can actually evaluate some functions on the page. Note that the page.evaluate will actually serialize the given function into a string and send it into the page, and evaluate the string as a function, then send back the result, which is also serialized. So, Phantom.js is very popular for functional and performance testing among web developers. And you can also use Phantom.js to crawl a page that, for example, if the page has some dynamic contents down them, you have to actually run the JavaScript on the page before you can actually review the topology of the website. It's also used for SEO when before Google actually have the ability to run JavaScript in their crawler, because you can actually run Phantom.js and render it into a static HTML file and feed it into, for the crawlers. And it also can be used for report generation, website archivement, and a lot of different things.
And Phantom.js has at least 8 million downloads, so that's why we say it's quite popular.
Yes. It's 7.9 million downloads so far. And Phantom.js can be used maliciously as well. You see, fuzz a page to find parts of the web page. You can it on the bot network. Here there is a report on a DDoS attack, which is using about 100,000 IPs running Phantom.js, and they are actually simulating different user agents, about 700 different user agents. And you can use Phantom for content scraping, login brute force attacks, click fraud, credential stuffing, beating war different ways. So web administrators tend to actually block Phantom.js in production. So if you're using Phantom.js for malicious use or not, well, you will want to actually cover your track, like you want to actually do this. Pretend you are somebody else. Okay, from this point, me and Sergey will play on the two parts. I will play the and he will play the website. I will try to spoof my user agent, and he will try to detect whether I'm. Okay.
Black hat and white hat, and just pretend we are. But we didn't find hats here in Denver, or suitable hats. So yeah, I will be the guy with that strange accent who, for some reason, pretends to be the good guy and to detect Phantom.js visitors on my website and try to do something about it.
And I will be the, sorry. Wait, hello? Hello?
Speak here.
Hello? Oh. Sorry.
Yeah, and Bei will be the bad guy.
Which I will be the Chinese accented bad guy with horrible grammar there. Yeah.
Okay, so just another sort of introduction. So yeah, we know that Phantom.js is running WebKit engine with like real JavaScript core and with real web core, real CSS stuff, but there must be something different from real browser. And here are the differences listed. Basically, WebKit itself doesn't implement, for example, network stack or cookie jar or the actual image generation. So somebody should do that for Phantom, and Phantom is based on Qt framework, and actually the Qt WebKit wrapper around WebKit. So Phantom is basically using Qt frameworks, network stack, and cookie jar, and lots of other stuff, like font generation, font handling. And yeah, that would be the difference pretty much between Phantom and the real browser, and we'll try to catch those differences. Yeah, another major thing that Phantom, by the way, introduces, it adds two properties to the window of your JavaScript environment. Window call Phantom and window underscore Phantom, but we'll come back to that later. And yeah, as a good guy, like what can I do? The simplest thing is to start looking at the user agent, right? Since we know that all versions of Phantom.js come with default value of user agent string that will always contain Phantom.js, so we'll just look for it. If guy says, I'm Phantom.js, why shouldn't I believe him? And what are you gonna do about it, Dave?
So yeah, what I'm gonna do? Yeah, user agent string. It's actually the first or the easiest thing. So Phantom.js actually provided you a API to spoof it. You can say page the setting, the user agent to like inside the HTTP header that the request has been sent, and the page window.user agent. The user agent string will be replaced with this. Yeah, that's all. Thank you. No, we're too busy like smoking pots and stuff. No, psych. Okay, so scoreboard. This time Phantom will win. Sergey?
Yeah, another thing to look at is, for example, plugins, right? Like we know majority of browsers there in the wild would have some kind of plugin handlers that handle content with MIME type that's not natively supported by the browser. And Phantom.js shouldn't have any because there is no no default way to provide Phantoms with Phantom.js with plugin handlers. So why wouldn't I check through JavaScript API what plugin array looks like? And if it's empty, then Phantom.js, like there are not too many people who are disabling all the plugins in their browsers. So that's a pretty good indicator. What are you gonna do?
Yeah, it turns out to be a kind of hard question. First of all, if you want to actually have some plugins in Phantom.js, it's basically impossible. You're gonna change a lot of C++ code to do that. And so you would try to actually spoof the navigator, the plugins object there. And the second problem is that navigator inside Phantom.js is read-only. And the navigator.plugins is also a read-only object. You cannot actually just change the length of it. And so this is what we do. We actually create new objects and set the thing we want to change, like the plugins.length equals to 1. Then we say that we change the prototype of the object to the prototype of the original object. Then when you say whether navigator instance of navigator, you know what I'm saying, right? So that will actually pass the test of his test. It's the same thing for navigator. So you want to change the navigator object by creating a new object and setting the prototype to the original one. Also, you may want to copy all the own properties from navigators and the plugins back to the new objects. So the object that has own property will, the navigator that has own property will act exactly the same as the original navigator. But there's a third problem, that since you cannot actually create a plugin, then if the website sends you a flash and require you to run it, you will basically no way to run it. So the conclusion will be it's not really a good ideal way to spoof this kind of things. So scoreboard. Second one, PhantomJS loses and the website wins. Sergey.
Okay, so there is, there is another knowledge that we gain from Phantom. We know that PhantomJS is going to suppress any kind of JavaScript-generated dialogues like alert or prompt or the confirm dialog or whatever, and which means whenever you pop an alert on the page, it's going to return immediately. So we can just start measuring it, right? And code like that would just measure the difference between creating the actual alert and when was it back. And if it's something like less than 15 milliseconds, then probably it's a bot or PhantomJS or just another bot in general. So looks like it's like hard problem for circumvent for you.
As we mentioned before, PhantomJS has only one JavaScript engine, but have different JavaScript contexts. So when you say prompt there, it's waiting for you to have an immediate return from some other parts of the JavaScript engine. So you cannot actually do that asynchronously, meaning that if you really want to wait like more than 50 milliseconds inside a prompt, you will have to wait it synchronously, which means you have to like run an empty loop for like 10 million times, and then you. This is the callback from PhantomJS for all the alert that's issued from inside the page. And this is horrible because, well, your PhantomJS can be DOSed by the website. And so this time the scoreboard will show that PhantomJS loses and the website wins. Okay.
Yeah, another thing to look at is, since I mentioned that one of the major differences between Phantom and the real browser, that network is implemented by Qt framework. So we noticed that there are like obvious differences. And for example, HTTP headers, we noticed that all modern browsers will put host header on top of the list, while Phantom wouldn't, like no matter which version of PhantomJS. And also, for example, keep alive or some other would be camel cased in PhantomJS and not in real browsers. Almost all real browsers except Opera 12, which was pre-Blink version of Opera. And now Opera is using the same engine as Chrome. So yeah, it's pretty reliable way to catch Phantom, right?
Yes, it is. In fact, the reason that host is at last in PhantomJS is because Qt Network Manager will actually initialize the request in a certain order. So the order in here actually reflects the order that the Q Network Manager actually generates the request. And it's really hard to actually spoof it. And if you want to spoof it, you have to change a lot of code inside Qt framework, which may not worth it. So actually there is an easy spoof. that you put a custom proxy in front of Phantom. And that proxy, inside that proxy, you can actually change the order of the headers. And as well as like want to spoof Firefox, then you change the header to Firefox. If you want to spoof Chrome, you change the header to Chrome. And you can use that for the lowercase stuff as well. So this time, the result will be Phantom wins. Circuit.
Yeah, as I mentioned, Phantom is adding these two properties to the window object of the web page's JavaScript context. So check for presence of those properties, and that's kind of clear indication that my JavaScript is running in Phantom.js JavaScript context, right?
Mm-hmm. Yeah, this one is like, this is the new functionality Phantom provided to the web page. The API here is pod inside web page instead of the Phantom.js script. So if you want to actually spoof it, it will be easy. Just delete them. You just delete window call Phantom in the beginning of when the page is loaded. Then this code, which is embedded inside the page, will not actually detect whether it's Phantom.js, whether it's Phantom.js. But a lot of cases, you still want to send callbacks from the page to Phantom.js. So you cannot just delete it. A solution here will be you save it somewhere else and define a property on window and the property name will be something the page cannot guess. And then set the property to be enumerable. Enumerable : false. Therefore, the script inside the page cannot or into a window to test whether there is like fishy properties in there. So yes, probably you just can't find whether there's a call Phantom call there. So this time 5 were 1, 2, 3. Yeah, Sergey.
Yeah, so we know the JavaScript engine of Phantom.js and like WebKit are old. So there is pretty high probability that HTML5 APIs are implemented. We didn't actually create any examples because it's sort of straightforward how to implement a test if the actual HTML5 API is implemented. Like web audio, if you don't have access to the actual mic or speaker, maybe it'd be hard. Maybe it'd be easy to figure out that's a spoofed one. Or like WebSockets are not RFC compliant implementation. Not RFC compliant implementation, and you can guess the difference from the WebSocket handshake, for example.
Guess I will just give up this time. It's too hard to spoof. So yeah.
Yeah. So checking for HTML5 features is probably gonna work for the from the detection side. So website wins. Yeah. Another major difference between JavaScript engine in Phantom.js that it doesn't support function prototype bind, and a lot of third-party JavaScript libraries actually rely on the existence of that bind, like jQuery and AngularJS are simply wouldn't work in older versions of Phantom, and that's the major or most popular on Phantom.js related websites, like, dude, when are you going to implement bind? My jQuery doesn't work, or like it doesn't work properly for all the cases. And yeah, the good solution is to just spoof bind or like implement something that would look like bind, function prototype bind. And yeah, Bay can get into more details.
So the code you're looking at is the, first of all, let me explain what is a function, the prototype, the bind. It's a function that is defined on a function that when you call function, some function dot bind will take the first argument of the call as the this pointer, or sometimes you call scope, of the function it returns. Say if you have a function that simply returns this, then you call this function dot bind with some other thing. for example, bind with document. Then when you call the function that's returned by bind, it will actually return document to you. So this is basically, okay. This is basically what it does. Take the function as this pointer and the self as the first argument, and then inside the return function, you call func.apply with the self and some other details. Okay. So one easy way to detect this is to say, okay, I would try to say that whether function.prototype.bind.toString result is actually a native function. So you can distinguish a native function and a spoof function by calling the function.toString. And then if you actually defining the function inside the JavaScript, the toString will actually give you the source code of the function. But if you're defining the function in a native way, then the content of the function will be a bracket native object or something.
Native code.
Yeah, native code, something like that. So by doing this, you can actually test whether bind is created, spoofed or not. But just leave with the question that, hey, toString is also a function, then we can actually spoof toString, right? So it will look like this. If this is bind, then we'll return a native string that looks like bind. Otherwise, we just call the original toString then. Well, you're spoofing toString, meaning that to detect that, you can call toString.toString to test it. Like this. So function the prototype the toString, call that and test that whether it's native code. Yeah, I have a question. Is it gonna work? Anybody know? Is this gonna work? Say if I say toString.toString equals toString. Okay, function the prototype.toString equals to function the prototype.toString. Then you can spoof it, right? No, not really, because the detector can delete function the prototype the toString, and the original toString will be reviewed. So we have to go back to the toString code and actually make a separate case of toString itself, like this. The original one is this equals to bind, then you return a native string. Now we have to say if also that is toString, then you return a native string as well. Then somewhere else we will call and apply and a function. For them, you have to do that as well. Another observation is that the function returned by bind is also a native function. So whenever you bind any function, then you should put the new function inside the list and test whether the list contains the function you want to spoof. And if that's the case, then you return a native string there. Now, this is a hard trick. And so far, we haven't found any way to detect this spoofing. So this time, weirdly enough, PhantomJS wins. It's okay.
Yeah. So, but there is PhantomJS 2 coming. Will be released pretty soon. It's not release date is not defined, but develop branch on their GitHub repository contains working PhantomJS 2, which has actually pretty up-to-date WebKit engine. It's like from January this year, but from now on it will be really easy to update WebKit that's running behind PhantomJS to like whatever the nightly build is. So it's going to be pretty fresh. And on the other hand, it's very bad news. It's pretty good news for Bay, because from now on it won't be possible to look at JavaScript engine differences and like make any kind of observations based on that, because there is a ECMA 5 test suite called Test 262, and PhantomJS actually fails. It's like 500 or 600 tests, or even more. I don't know. It fails only 2 tests, and those are exactly the same tests that fail Safari 7, for example. So by looking at JavaScript engine, it won't be really possible to tell the environment your script is running in. And
so So we have to move to something that's
Yeah,
not in this.
which means we need to move to something that's different from the actual like JavaScript engine properties. But we're not moving too far. It's still produced by JavaScript. So we know that looking at call phantom is unreliable, but let's look at the stack trace. So I tried to run a code that throws an error, and from error object in any browser, although it's not a standard feature, but any error object would contain the stack trace. The place in the actual error was thrown. And we ran that code in Phantom.js and in Slimer.js, which is Gecko-based headless browser. And like stack traces are completely different, but there's one common thing. They both contain Phantom.js : // and let's try to do something with that. So we not figured out, but it's sort of natural. So everything can be spoofed in JavaScript. As in Bayes' bind example, you can see that JavaScript is a horrible language, and yeah, pretty much everything can be spoofed. But we know some fact which can help us. So if you make JavaScript engine to throw an error, it's not like your code is throwing an error, but you're making JavaScript engine to throw an error, then non-modified error object will be thrown. We'll get to that catch state, catch clause. And by that, we can look at that errors stack later and see if it contains Phantom.js, then probably it's either Phantom or Slimer or any other like Phantom.js-based user agent. And yeah, it turns out that it's quite difficult to spoof the stack trace.
Yes.
What can you do?
So stack trace, first of all, stack trace is not part of the ECMAScript spec. So every browser have its own way to like format the stack. Like different browsers will have a different way to format the stack. So at least that part, the Phantom.js part, can be removed because the string have to show up somewhere in the source code. So we grab the source code and find this. So that piece of code is the part that Phantom.js : / is injected inside the call stack. Then we remove that code, we get the stack trace like that. At empty. Well, this is not very nicely looking because it still is quite different from any other browsers like this. So we added some other things inside the Phantom.js, and we try to spoof Chrome. Inside Chrome, if you use DevTools, the injected script will be showing up in the stack trace if you're actually initiating a function from the developed tools. So we added that part, and it's still looks really different from the original one. So this is actually a very good fingerprinting fingerprinting technique for Phantom.js.
And not only Phantom, but for like any browser. Like if you know how Google Chrome stack trace would look like, or like the structure of the stack trace, then you can probably always write pretty complicated regular expression that would tell you if it's like real Google Chrome stack trace or not.
So the scoreboard.
And there's another observation. As you can notice that Phantom.js is putting, on the last line, it puts a full absolute path to the file, which is the actual Phantom.js script. So we will use that knowledge later.
Yeah. So the scoreboard will be, this time, Phantom.js will definitely lose. We have other ways to fingerprint, actually many other ways to fingerprint a browser. Like, since you know Phantom.js is using WebQT graphics engine to render all the page, then you can actually do a canvas fingerprinting. Just like draw some random elements on them and get the data from the canvas, and then hash the data. Some techniques like that will perfectly detect Phantom.js. So now that there are other ways to actually spoof them, but for now we have a score 4-4. Sergey.
It's actually like this. So yeah, we went through many different ways of detecting Phantom.js, and that will lead us to a natural question. What can we do once we caught malicious Phantom.js or unwanted Phantom.js in the
Before
wild?
sliding, anyone want to know what that is? This is
Even I don't know.
okay. Yeah, I think it's right.
Some kind of movie or?
It's a comic called Titan. It's a Titan. Yeah,
Okay.
okay. Anyway.
Yeah. So once you figured out that a user agent that visits your website is unwanted Phantom.js instance. So because of this, since like normally most of the people are running Phantom.js as the same user as their shell, dangerous. Or we know there's no sandboxing, and Phantom.js is running, all the pages that you open in Phantom.js will run in the same process space, not like in the browser's own process space. And like Qt itself has a lot of outdated, you can search for Qt vulnerabilities and you'll see reports on either using outdated libpng or libxml or font handler or I don't know, GIF parser, a lot of attack vectors on that layer as well. So it can possibly lead to the Phantom.js process itself or maybe the operating system. So first example, it's based on that stack trace technique, looking at the stack trace of thrown by JavaScript engine error. It's just sample example, but you can extend it as much as you want. The first trick is to make Phantom.js execute the code that actually throwing an exception. So how to do that? To pick some popular API like query selector all, or you can pick, I don't know, get element by ID or something that most likely Phantom.js script would in the web page context, and just overload that function. And what it does, it checks, it throws that exception, we check the stack trace for the presence of Phantom.js, and if it turns out it's Phantom.js, then query selector all can do something stupid, like return HTML element instead of the current matching element of the page. In the else clause, we'll just call original query selector all if the execution environment is not, it doesn't look like Phantom. So it's pretty, you cannot call it detection already anymore. You can call it pretty much, I don't know, the Phantom.js functionality disruption or something like that. Yeah, another common scenario is having same origin policy turned off in Phantom.js, because lots of third-party tools that are using Phantom.js for the network layer, like instead of curl, because Phantom.js evaluates JavaScript and things like that, they started using Phantom.js, but they don't really care about same origin policies. So they either hardcode web security equals false argument they launch Phantom.js, or they recommend you to launch Phantom.js with same origin policy off. It's quite dangerous because the file path of the file that you want to access, it'd be actually as easy as something like this. Origin policy, it will be able to actually read the file using XML HTTP request. And since as I showed, Phantom.js also puts the full path of the file it actually puts full path of the file that throws a stack trace or that generates the stack trace. It will be possible to actually steal the Phantom.js script from the attacker who visits your website using exact the same script. And yeah, another point is me as a detector of malicious, I can always randomize things, like randomize the APIs that you are messing with, as in the previous example where we throw that, where we detect the stack trace. Like I don't know, on first request you can overload query selector all, on second one you can overload any other API that possibly will be PhantomJS, in PhantomJS, by PhantomJS script. And or like obfuscate the code. It'd be pretty hard for the attacker to figure out what's happening and to take to apply some countermeasures against it.
So to wrap up, there are several things you need to worry about. If you don't need PhantomJS or any full-blown browser engine, for example, if your task can be a curl script, then you not use them. And second one, you should definitely not run PhantomJS with it can read any file on your file system if you have to access. If you run root, actually it can like steal your /shadow file and send back to some remote server. You're going to be doomed. And so you should avoid opening internet. Well, I guess everybody should take that. Not only PhantomJS. Okay. So no root. You should just use change root. Create a child process for every page because a page will show that a page can be very easily crashed. The PhantomJS process can be very easily crashed by a page. And then if security is a requirement, then probably try alternatives. Say,
use Chrome controlled with Selenium, because Chrome has much more security.
Yes. Other side, for the web administrators, you should try to say to spoof a user agent is hard, but to detect the user agent is also hard. If you don't want to detect the user agent, try to. Second one, if you really want to stop the from the PhantomJS, to spoof it is actually a good, turn out to be a very effective way because the other part will try to bait out. A little bit technical will be okay. So we mentioned a lot of different ways to detect it. You can reject known unwanted user agent. A good start will be 5G blacklist 2013. I think they have
I don't know.
this year. No. So then something like that.
Yeah, and just to really wrap up, so we gathered examples in this repository. It's like really working. You can really like, copy a piece of JavaScript into your page, and you'll start and implement some kind of reporting, some kind of feedback back to your server, and maybe you'll start getting reports of PhantomJS visitors of your website. This repository covers probably more use cases that we went over in the slides. Like, I don't know, you can look at the screen size and in the examples. And I will see if I can switch to my probably. If I what?
No, the command line is different.
Oh, yeah.
Remove
yeah.
the clear. Remove the clear.
Okay, I can clear.
Remove the clear.
Oh, remove the clear.
Yeah. There's a clear over there.
Yeah, I don't see the same screen. So, yeah, another way of abusing PhantomJS, but we didn't put it in our repo, is to just to search for already vulnerabilities, and most likely they would work on PhantomJS, because if it's old PhantomJS, I don't know, even like 4-year-old WebKit vulnerability exploit, and it probably would work. And if you are abusing Phantom 2, which is not even released yet, then you probably can pick something fresher. And this one is based on implementation in older Phantoms, or in older WebKits. It's pretty reliable. Arbitrary codex will just take some time probably to.
So there is a function inside JavaScript called a string join. Fail to check whether the length of the string actually overflows. It will actually have a mem copy with negative length, which
I
is
have crash report open here,
Yeah,
because it might take like, I don't know, 3 minutes, but this one is like very reliable exploitation technique. It happens in mem move, and yeah, if you're really desperate and want to own someone who runs Phantom.js and visits your website, it's pretty reliable technique to own the actual operating system if it runs as root. Let's see if the video crashed. Oh. Anyway. Yeah, here are some references that we used in our slides, and that's pretty much it.
Any questions?
So I know that Phantom has some issues with 302s. Have you guys used that for detection?
302.
Issuing an redirect?
Well, I know about one issue in Phantom.js around 302. Like if I know that Phantom will apply same origin policy check for XHR, like for XHR, but if for XML HTTP request, but response to that XML HTTP request is 302 to a local file, it's a way to bypass same origin policy file. I think it's coming from QT network stack. It's not like Phantom implements anything around it, but I think there's a patch for that.
So tried it. We reflection server that always reflects a file on the attacker's machine, and it didn't work if you have web security to true.
Yeah, now that will only work if you disable web security.
Not necessarily as an attack, but more as a prevention technique. Because I know for QT, it's not happy about following the redirect in order to send the browser to the next page. So to bypass some of that, at least as an initial stop.
We are not really aware of.
We didn't observe that. Thank you. Questions? Okay. Thanks, everybody.
Thank you. Oh, it actually crashed.
Actually crashed. Okay.